Okay, we're looking at the dot product of an algebraic vector. This is lesson 7.4. We've gone over some rules. Essentially what we added is vector x dot vector y we already knew was equal to the magnitude of x times magnitude of y times cos theta. But it's also, in terms of component form, equal to taking the component or the first term of x and the first term of y, multiplying them together, and then adding the second term multiplied by the second term in each, and getting a value. Again, it's going to be a scalar. It's just going to be some number, not a vector in itself. The same thing holds true for 3 space. The only difference is there's an A3 and B3 at the end. Same formula from above. And this is just rearranging our original dot product formula. So let's go to the next page here. Given that vector A is at this point and B ends at this point, -1, 2, 4 and 3, 4, 3, figure out what A dot B is. Well, because we're in component form here, we're going to use our component formula where A dot B is equal to A1 times B1 plus A2 times B2 plus A3 times B3. Okay. And this is our A1, 2, 3 and B1, 2, 3. Okay, so what that gives us is -1 times 3 plus 2 times 4 plus 4 times 3. Okay. We get -3 plus 8 plus 12 gives us 17. So the scalar or the number for vector A dot vector B, the dot product of the two, is the number 17. Now, from there, they may ask us, let's say part B is, determine the angle between A and B. So angle between vector A and B. Okay. Well, remember we had that formula. When solving for the angle, we do our cos theta is equal to the dot product of A and B divided by the absolute value of A and the absolute value of B. Now, I'm going to refer back to something we learned a little while ago. Okay, the absolute value of vector A. Vector A had the values of -1, 2, and 4. 1, 2, and 4. -1, 2, 4. And vector B had the values of 3, 4, 3. We know what the dot product of A and B is. What is that number? 17. We already figured that out, which is good. We know the top of this fraction. Bottom of this fraction, the absolute value of A. Well, we have 3 points. And if you guys recall, our 3 points, or with our projection vector, can be solved by something similar to Pythagorean's theorem, just in 3 space. And what it is that the absolute value of our A in this case is equal to the root of A squared plus B squared plus C squared. But these are no longer called A1, A2, A3. These values are A, B, and C when referring to that. And that's the case for both of them. Okay? So we're going to use that formula to find the magnitude of vector A and the magnitude of vector B. Okay? So to find magnitude of A, we're looking at -1 squared plus 2 squared plus 4 squared, all rooted, which gives us 1 plus 4 plus 16. We're looking for the root of 21. So root 21 is the magnitude of vector A, and we'll do the magnitude of vector B right beside it. Same formula as before. Write it in just so we have continuity here. 3 squared plus 4 squared plus 3 squared. Ah! There you go. gives us 18 and 16, 34. Root 34. So, when solving our angle, we go back to our original formula. Cos theta is equal to, we knew the dot product of A and B was 17, divided by root 34 times root 21, which is going to give us 0.6362. And then to find theta, the angle, we bring it over, or cos inverse. Remember, that would be like second function on your calculator. Okay, so don't raise cos to a power of -1. Make sure you hit second function. That's how you find it on your calculator, because cosine is technically an equation, and we're plugging this number into that equation. Theta is equal to approximately 50.5 degrees. So in that one, we found what the dot product was, and we found the angle between vector A and vector B using our algebraic numbers. Okay, a little simpler than the last way we did it.